Well, hello Internet, and welcome to my Arduino C programming tutorial. In this one tutorial, I'm going to cover pretty much everything you can do C programming wise with an Arduino. Now, of course, I'm not going to be able to cover all the different types of hardware, but I will cover a lot of different hardware in regards to how we're going to use an Arduino, but I will cover pretty much everything you can do C programming wise. Like always, all of the code is available in the description underneath the video. I am also going to link to a kit that I am going to be using, and of course you're going to need an Arduino Uno if you're going to do this tutorial, or something like an Arduino Uno. And you're going to have to connect it to a USB to your computer, and everything works exactly the same on Mac as well as on Windows, and I have a lot to do, so let's get into it. Okay, so in regards to software, what you're going to need, I was going to use Visual Studio Code, but I thought there was a very likely chance it might change. This is going to be the Arduino IDE, and this is what I'm going to use. However, you can use Visual Studio Code. It works pretty much exactly the same way. All right, so arduino.ccen main software, or you can just go to Google and type in Arduino IDE, and you will see this tutorial. And this Arduino IDE is what I'm using, and you can see it's available here for Windows and Mac and Linux, and everything works exactly the same. Alright, and here is the Arduino software we're using. And this on the right side is the serial monitor. We're going to be able to communicate with the Arduino and have it communicate back with us. And whenever you go File New, you're going to get this to open up, and it's going to look exactly like this. And one thing you're going to want to do is go to Tools and then Board, and make sure you have Arduino Uno picked, which is right here. And then over underneath Ports, you're going to want to check one of these ports to see which one works for you. Alright, and whenever you do that, everything will be ready to go, and I am ready to write some code. Okay, so what I'm going to do here first is I'm going to define a constant, and that means this value is never going to change, and I'm going to call this an integer because I am going to be storing a value inside of it. And what I'm referencing right here is an LED pin on the Arduino board. It is a light that's going to light up on your Arduino, and integers are going to have a value between negative 32,000 and an upper value of positive 32,000. Actually, it's slightly more than that, but I'm going to keep it that way. And then you will know, don't go under negative 32,000, don't go above positive 32,000. Okay, so we have an integer here, and I'm saying that the pin that I want to reference is 13. And this is outside of any of our functions. This is a function, this is a function. And so what that means is this is what we call a global variable, meaning that this value is going to be accessible to all of the other code in our program. And you do not want to have a lot of these in your program because it can become confusing, because there's values changing all through your code. You want to pretty much keep everything inside of functions themselves. So that's the basics there. And inside of setup, as you can see, put your setup code here. This is where you're going to initialize or set values for different things that are important. Another thing is we want to be able to talk to the serial monitor. Once again, it's over here. And to do that, you have to start off by going serial begin and 9600. And what this means is this is going to open up a port that's going to set how many bits per second, and 9600 is equivalent to 960 characters per second, and it's pretty much a standard, so that's what I'm going to use here. Now, if we want to be able to light up the LED, and of course you're going to have a USB plugged into an Arduino into the back of your computer to be able to do this. But if you want to be able to use your LED to turn the light on and off, you're going to reference your pin that we have there, which is 13, and then you're going to have to say that you want to use it for output, which means that you want to be able to change the value. And I just said that I want to save this, and I'm just going to call this Arduino Tut and save. Okay, everything's the same on Windows and Mac and Linux. All right, so after we have that all set up, we're going to be able to come down here to the loop section. And as it says, you're going to put your main program code here, and it's going to be run over and over and over again. Hence the term loop. Now what we're going to do is, this is a global variable. What we're going to do is we're going to create some local variables that are going to only be available inside of the loop function. One thing we're going to do is we're going to turn our LED on and off. So we are going to define another integer, and we're going to say how much time we are going to delay well, we're going to turn the LED on, and then we're going to hit, this is a 1/10 of a second, it's going to be on, and then it's going to go off again. Okay, so that's what that is, 100 milliseconds. We are then going to say that we want to turn our pin on, which is the same as the LED. And to do that, we go LED pin and we say high. And that just means that it is on. And you can see LED pin is referenced there both times. We are then going to say that we want to have it stay on for a certain period of time, and that is going to be our delay period. And we can say that. And then after that, we're going to say that we want to once again turn the LED pin off. And to do that, we say low. And this is a standard way just to test that our Arduino is working properly for us. Okay, and then after we have that, we turn it off. We want to once again have it be off for a certain period of time, and then it is going to start up here, turn on, turn off, turn off, turn off, over and over and over again. And now to test that our code actually works, we want to have it saved. Then we're going to come over here and click on verify, and you're going to see down here if there's any errors. There are none, so you're going to click on upload. And whenever you do, you're going to see that your Arduino is going to blink a couple times, and then its LED is going to blink pretty quickly on your screen. Now what I want to do is I want to increase the delay period between the LED blinking, and then I want to go backwards and have it speed up and slow down, speed up and slow down over and over and over again. So how am I going to do that? Well, I am going to just come inside of the code that we already wrote, and right after this guy, I am going to put some more code in here. So what I'm going to do is I'm going to say if my delay period is equal to 1000, which is going to be the maximum amount that I want to wait, or 1 second. Or, so this is a condition, and this is going to be another condition. The delay period is equal to 0, which is going to be the minimum that I wanted to wait. And there we go. And you can see, make sure you have all your parentheses closed. So if either of those is true, I want to go and say that I want a variable called direction to change. So I'm going to multiply this times -1, and that is exactly the same as if I would say direction is equal to direction times -1. So that is going to change that little variable for me. But as you can see, this function we have here is starting to get kind of long, and we're going to be adding even more code to this. So what I want to do is create another outside function that I can then call to keep my functions a reasonable length overall. So I'm going to start off using good coding practices here right from the beginning. So up here, right after this variable has been declared, I am going to come in and I'm going to create another integer, and this is going to be count direction, and I'm going to have it set to 1 first off, and maybe we put a space there to make this a little bit more readable. And then I'm going to take this guy right here and cut him right out of there, and I'm going to go count direction is going to be equal to, and I'm going to create a new function called check direction change, and I'm going to throw into that, I'm going to pass some values over to it, which is going to be our delay period and our count direction, and it's going to return information back to us. So let's create that function right now. This function is going to return an integer, of course, because this is an integer, so that makes sense. And I'm just going to say check direction change, and this delay period is an integer, so I'm going to have this be an integer, and I'm just going to let it have the same name. Sometimes that's a good idea, sometimes not so much. And then int count direction, and these are going to be completely different variables from these variables, so even though the name is the same. And then inside of it, I'm going to paste in that code I started throwing inside of there, and I'm going to change this from direction to count direction, and then I'm going to continue. Then I'm going to say if an if statement is going to perform an action if a given condition is true or not. So I'm going to say if the current count direction is less than 0, which means my delay period is 0 or greater. Well, in that situation, well, I'm going to write out to my serial monitor that a change has gone on. So, and that's going to be over here so that I can see it and know what's going on even though the Arduino is just sitting here blinking. So I'm going to say going down and then close that off. If this doesn't totally make sense, it will as the code starts executing and things start popping on the screen. Again, I'm going, and the print line means that we want to put a new line over here on this side of the screen each time we print out some code so that there's a line break between each thing that prints out on the screen. And then after I do that, I can say return count direction and close that off. And now that I have that function defined, what I can do up here is right after this guy, and once again this is in my loop function, I'm going to come in and I'm going to change my delay period, and this is going to be plus equal to 100, that's 100 milliseconds times the new count direction. And once again that would be the same as dp is equal to dp plus 100, okay? Where dp is the delay period, this guy right here. All right, so that's just a shortcut way of doing that. So that's going to allow me to increase and decrease the amount of delay that I have between the LED turning on as well as turning off. And let's say I also want to print out a message over here on my serial monitor so that I can also get a little bit more information. So I'm going to say print, and here that means I do not want a new line after this. So I'm going to say, what is the new wait time? And close that off. And then afterwards, we can throw in a new line. And then we'll say delay period. And there that is. Now, I on purpose made a mistake so that I can show you what's going on. So we're going to go in here and compile that and then load it. And you're going to see over here on the right side of the screen here in a second, new wait time. And you can see that it's 200 forever. Why is that? Well, the reason why is each time we come in here and we go, whenever we loop, these values are going to be reset. So that's going to be reset to 100 and that's going to be reset to 1. That's a problem because we are changing those values down inside of here. However, they're not going to go and turn the light on the LED on and off like we want to, because these values are being set to their original value each and every time. There is a way around that, however. And the way around that is the delay period is what we want to be able to change. So what we're going to do is we're going to come in and we're going to put static in front of that. And what static means is that we only want to initialize or set a value for this one time, and whenever we come into loop the next time, we do not want it to be reset to 100. We want to start it off at 100 and then be able to change it each time through the loop. So once again, we're going to click compile and we're going to run it. And this time you are going to see on your LED that the wait time is going to slowly increase. And I'm going to show you my Arduino doing this here in a second. So it's increasing and then it is going to, see, going down. Well, it looks like we have a little bit of a bug. Let's go in here and fix that. Well, so did you catch the bug? Kind of did that on purpose just to test you out there to see if you were paying attention. I'm also going to have the count direction set as static as well. And if I do that and re-upload, you're going to see that it is going to work exactly as we had planned. So the wait time is increasing, and then once it hits 1000, it is then going to turn around and the wait time will start decreasing, just like we see right there. And now I'm going to jump over and I'm going to show you my Arduino and exactly what this looks like on the Arduino, and then we'll get back to writing more code. You can see here on the Arduino, it is going to get slower and slower and slower, and then eventually it will start speeding up just as we had programmed it to do. Okay, and we're back. One thing I wanted to mention is right here where we said we were going to execute this code if this was true or that was true. I just wanted you to know that you can also put two ands inside of there, or ampersands, and that would say that we're going to execute if this was true and this is true. But in this situation, we only need one of them to be true for our code to work. All right, so let's come back up inside here and I'm going to go and do a couple more things. I'm going to create create a function inside of here that is going to do a countdown before it starts manipulating the code. And I'm going to pass the value of 5, and that means it is going to go and it's going to print 5, 4, 3, 2, 1, and then go, and then it's going to start executing this code. So this function is going to come down inside of here, and I'm going to start writing it. Okay, so this function is just going to perform an action, so it doesn't need to return a value when it executes. So in that situation, you're going to type in void, and it's called countdown, and it is going to receive an integer, which is going to be the maximum number that it wants me to print and then count down from, and then do whatever. Now what I'm going to do is I'm going to introduce a for loop. That's basically what this guy is right here, this looping structure that we have. However, this for loop, instead of executing indefinitely, is going to execute a certain number of times, and that is going to be the max value. So we're going to define another integer inside of here called I, and we're going to say that it has a maximum value of the max they passed in, and it is going to continue to execute as long as the value of I is greater than the maximum value. And with for loops, and then on top of that, we are going to increment the value of I each time through, and this is the same as doing I is equal to I plus 1. All right, and there that is, and make sure you have your curly brackets set up right. Now with for loops, we're going to be able to perform conditions on greater than, less than, greater than or equal to, less than or equal to, and that's basically it. But of course, we're going to be able to do and conditions or conditions if we want to have multiple conditions. Okay, so we're going to come down here in the for loop, and we're going to say we want to print, and we're going to print out I, and this is going to be our countdown. And then we're going to say serial print once again, and we're going to put a comma inside of here, and then close that off. And then after it counts down, we're going to finally say serial print line, and we'll say go inside of it. So it's like a silly little countdown. And if you want to force a new line inside of here on top of the other new line, we can just go like that, and there we are. Okay, so we got the function created, and we called the function right up here before we did anything else, and now we can execute the function, and you can see what it looks like. So it's just a simple little countdown. And it didn't print because this actually should be 0. And I'm decrementing. Forgot I was decrementing. So let's go like that, and then let's run it again, and you're going to see that it works properly this time. And there it goes. All right, so there's another example of a function and something we can do with for loops. Now there are other ways to loop inside of C using Arduino. Another way is what's called a while loop. And a while loop is going to continue looping forever as long as a condition is true. The one thing is you're going to have to define the variable you're going to be working with outside of the while loop. So I'm going to say while the condition of j being greater than 0 is true, I want to go and print out. Let's just go and copy the code that we have right here. So there's that. I want to continue going and printing out these values, except we're going to change that to j, and then we're going to have to decrement j underneath of it. So the while loop and the for loop are very similar fellows. So let's go get that. And then we can go and throw this right here. And if we do that and upload it to our Arduino, you're going to see that it's going to do a countdown from 3 instead. All right, so there's an example of a while loop. Another thing we can do is let's talk about some different values we can work with here. And one of them is called a float. Now, a integer is not allowed to have decimal values. However, a float is allowed. So we're going to say that we want to create a function call down here called add floats that's going to return a float, and it's going to be number 1, and we're going to receive another float which is going to be number 2, and it's just going to return those numbers added to each other. And you're going to see here how precise this is, which it's not terribly precise. And make sure you have the closing curly bracket. All right, so add floats is what we're going to be calling. And we can come up inside of here right after we printed that and paste this inside of there. And just for the heck of it, let's go and create another one called add doubles. Now add floats and doubles, unlike in many other languages, are exactly the same in our Arduino. And what we're going to do is we're just going to call this add doubles, and change this into a double as well, and this into a double as well. And I'm going to show you through an example that they are the same thing. So add doubles, and we'll come back up here, and we will go and throw that in there. Now what I want to do is I want to go and do a print out to our screen. And inside of this, I'm going to say 3 point, and then I'm going to go and create 8 ones plus and a 4 and more ones, 8 ones again, is equal to, and then this right here. And then I'm going to call these two functions, and if you're used to other programming languages, you might think you're going to get different results, but you're going to see with Arduino that you get exactly the same results. So I'm going to call add floats, and then I'm going to pass those values inside of it. So let's just go, and you can also see that you can go and call functions from inside of your print statement without any problems at all. And then get this guy right here and paste that inside of there. And whenever you see, whenever I close these parentheses, you're going to see a little blue box shows up. That's just a nice easy way to see that they have changed. And why don't we just go in here and just do this again and paste that there and add doubles, and then we'll just go and add this part onto there. That works perfectly fine. But what I'm also going to do with the print line is I'm going to say that I want to have 8 points of precision for my doubles, and how I can do that and my floats is I just put a comma inside of there and then follow that up with an 8. And now if I run that, you're going to see all this other stuff pops up here, but you're also going to see the precision of a double as well as a float. And as you can see, they only have 1, 2, 3, 4, 6 points of precision before they mess up. And just so you can see, the float is exactly the same. So whenever you're working with doubles or floats, just be aware that they are only precise up to 6 digits, and then after that, they go absolutely haywire. We also have additional data types that we can work with, and I'm going to show you pretty much all of them right now. So we're also going to have booleans, which can either have a value of true or false. And I'm going to go can vote is equal to true. And then I'm going to show you another way of doing things conditionally, and this is called the ternary operator. So I'm going to say print and can I vote, and then follow that up once again with another print line, and I'm going to put my condition inside of here. So I'm going to say can vote if it's equal to true. Well, in that situation, then you're going to put a question mark. If that comes back as true, that condition, then the output is going to be yes. Otherwise, the output is going to be no. And then I'm going to make sure I close my parentheses and do that. And then if we run it, you're going to see that it's going to print out yes next to can I vote. And this is called the ternary operator. Can I vote? Yes. All right, so there's another thing we learned. What else can we do? Well, we can also store individual characters. So I'm just going to have letter D is equal to, and now whenever we're storing individual characters, just be aware that they have to be surrounded by single quotes. And of course, you could go and print out that value if you would like to. All right. And also other data types. This is basically it. If you want to use values between 0 and 255, we're going to get more into binary and stuff later on. You can use a byte. You can also define unsigned integers, which get to be bigger. Remember, the maximum size for an integer is 32,000. It's actually 32,700 and something. But like I said, you can see that doubled. We can also use longs, which are much longer, and then unsigned longs, which are longer even yet. You can also see here an example of a comment. If you want to put something in your code that is completely ignored, just put 2 forward slashes. And for a multi-line comment, you're just going to go and put a forward slash and a star, and then you can have a multi-line comment. So there we go. And now I'm going to start up another block of code. Now what I want to do is talk about arrays. And you can see here I went and got rid of a lot of the code we had previously. So what am I going to do here? Well, basically an array is just a box inside, a whole bunch of boxes inside of an individual box. And an array can contain many different values, and each of the values stored inside of it has an index or an address, whatever you want to consider it, that starts with a 0. So let's go and let's define an array that is going to represent the number of blinks that we're going to want. Now it's going to be a bunch of integers, so we're going to put int in front of it. And I'm going to call this number of blanks. And to designate this as an array, you just go and put those brackets inside of there. And then I'm just going to say 1, 2, 3, and 4. And that's one way to create an array. And once you define the size of an array, that array size cannot be changed. Everything here can be exactly the same. And let's go delay period. Let's change that to 1000, that's 1 second. And let's say I want to change a value in an array. You can change a value in an array. You go number of blanks, and we can change the first one to say 5 instead of 1, which it was, and we'll just go equal to 5. All right. You can also define an array without going in and actually putting values inside of it. However, you're going to have to say how big you want it to be. So that time I said I wanted to have 10 little places to store values inside of it. You're also going to be able to store a string of characters, and let's go and create, that would be a character array. And we're going to see more about strings here and more about all kinds of stuff. Pointers even, and all kinds of stuff. So there you go, and that is how we go and create a character array. And in actuality, a pointer just points to the first character in our address for our character array. So we can come in here and also go character star str is equal to and bananas if you would like. And there we go, created that. Like I said, we'll do more with pointers here in a second. You can also print this string just by going serial and print line, and there is our string. Let's go, and I'm going to do a whole bunch of different things with strings, and then you can see the output on the right side of the screen after that. You can also define just a regular old string like this. So my name is equal to, and I can type in my name. There it is. You're going to be able to combine strings. So serial, once again, print line. You're not able to do this with non-strings, but you can do it if you're working with 2 strings. So I'll say name, and then you put a plus sign inside of there, and whatever the name of the other string is. What else can we do? Make sure you spell serial correctly. And we can also get the length of our strings, how many characters are inside of them. And we'll get back into arrays here in a second. Just wanted to go and cover this because I was talking about strings there. And we can also check for equality between our different strings. So go print line, and you would just put whatever the name of your string is, and then this is going to return true or false depending upon if the string is the same or not. And we could go equals, and then what you want to compare it to. So this of course is going to come back as being not a proper comparison. You could also go and do equals ignore case if you wanted to ignore upper and lower case instead of just typing in equals like I did right there. You could also get a character at a specific index. Remember that we are going to just go print line, and then once again just go and get your, well, I'm going to show you a couple different things. My name, and let's say we wanted to do the character at the 6th position inside of our string. We can do that way. We're also going to be able to get the index that matches a specific character that we have inside of it. So my name, and to do that you go index of, and we're going to be able to use substrings to find bigger things also. And you could also come in and remove a block of characters inside of it. So let's say we wanted to come in and we wanted to start off removing things at the 0 index, and then we wanted to remove a total of 6 characters that followed after that. You can do that. We can, let's go and print that out on the screen since we changed it pretty dramatically. And there it is. We can also replace one substring with another. So I don't know if you noticed, but my name is not actually bananas, it's Banas. So let's say I wanted to go in there and make a change to that so that I had the proper name. I could go replace and NAS, and then get rid or then put just an S in place. We can do that. Let's go and print the name again so that you can see the changes that are taking place. And what else can we do with strings? We could also get a substring and print that out on our screen. And to do that, we just go my name and then substring. And let's say we want to start at the 0 index and then get 3 characters after that. We can do that. We're also going to be able to change from uppercase, change every single character to uppercase. So uppercase, and likewise, we will be able to change everything to lowercase. So let's just do this. And we could also convert a string to an integer or a float. So let's go and create a string. Let's call it 1 and put that there. And remember, it's double quotes for strings and it's single quotes for non-strings. And then we want to put it inside of an integer. And to do that, we would just go 1 and 2 int. And I said we could also do the same thing for floats, just by typing in to float with an uppercase F instead of an uppercase I. And let's also come in here and do a sum, and that would be number 1 plus number 1. We'll be getting a lot more into math here in a second. And then let's just go and print that out. So print line and print out our sum, so you can also see that on the screen. Also, likewise, I want to show you how to cycle through arrays, because we were talking about arrays previously. As you may have guessed, that is going to be done with a for loop. So I is equal to 0, and we're going to continue cycling through as long as I is less than 5. And then we're going to go in and we're going to increment the value of I. And if we want to go in and print those out, we can say print array 3 is what I called it, and I, and then that's going to print out all that. And that is array 3, which is this guy, which is just my name. It's going to print it without putting new lines down each time. And let's say I'm also going to want to go and blink my LED a certain number of times. So I want to basically blink my LED like 1, and then 1, 2, 3, 4. It's actually going to be slightly different because I changed the value of our array. See, like here, but I went and changed the value to 5. So our LED on our Arduino is going to blink 5 times, and then 2 times, and then 3 times, and then 4. Well, I'm going to do that inside of a function, and I'm going to go and get this part right here and cut that directly out of there just so we can go and create that. So it's not going to return anything, so I'm going to put void inside of there, and I'm going to call this blink LED, and it's going to receive the number of blinks, and go put that there. Then I'm going to say for and int j is equal to 0, and we're going to continue blinking as long as j is less than number of blinks, and then we will increment the value of j, of course. And I'm going to show you what all the stuff I just did with strings here in a second. We can paste that inside of there, digital write. Let's go, whoops, put that in there so that everything lines up. It's very useful to have all your code line up properly. And then let's just change delay period to 400 and 400. Just to have consistency with that guy. And then what we'll do is we'll pop up inside of here, and we'll go and create another for loop, and int I is equal to 0, and we're going to continue running this as long as I is less than 4, and then we will increment the value of I once again, and then I'm going to call my function blink LED, and I'm going to pass in number of blinks, and that is going to be the array that we created very early on whenever we created this stuff. See, number of blinks. Just remember it's going to blink 5 times first. So we went and we called that, and then we can go and put an additional delay between each of those guys, and we'll have delay period, which I believe I still have defined inside of here. Yeah, delay period. So there's going to be a full 1 second blink inside of there, while there's going to be a 400 blink between the blinks on our LEDs. Just trying to do some different things with the Arduino, and let's go and run it and make sure. I have a little bit of an error. Oh, I see what it is. This is uppercase and lowercase. All right, got that saved, and now we can execute it, and everything should be working perfectly fine. And you're going to see that all of that information in regards to what I was doing with the strings prints out, and you're also going to see that your Arduino is blinking a set number of times based off of these values. But let's just run through exactly what we have over here. So serial print line, and it is going to print out, which one is that? Bananas. That's because that's bananas. And then it's going to go name, and it prints out that. We're going to say the total length is 13, as you can see on the right side of the screen. Is it true? Comes back as 0, which we are getting that right there. Whoops. Got a little bit messed up. Let's run it again. Sometimes the serial monitor gets a little wacky. You can also see character at 6, and there is the index, and then you're going to see all the different manipulation we did until we finally cut it down to BAN. All right, and there is all that information about arrays and strings. And now I'm going to cover a whole bunch of random things that I haven't covered so far. Alright, so to keep everything simple, I'm going to do a lot of this coding inside of the setup function here. So what I want to do is I want to create a character that's going to represent a grade, and then I am going to go and show you the switch statement. Now basically the switch is going to perform different actions based on a limited number of possible values. So what we're going to do is we're going to check the grade that we just entered inside of here, and we're going to see what the value of grade is and then perform different actions. So we're going to say that if grade has the value of capital A, well, in that situation we are going to print out great, for example. And then to jump out of the switch statement and stop checking, we are going to put a break inside of there. Now what we're going to do is we're going to do this for a whole bunch of other different potential letter grades, or whatever you want to refer to them as. So maybe they got a B, and we're going to say good, and we could continue on. And in the situation in which none of the conditions are true, we're going to put in default, and then we are going to come in and print out a different message. So we'll go default, and we'll put something like confused inside of here, and then break, and then that's it. All right, so I think that's the simple way of understanding how a switch statement works. And you can see here, if I load it over, that it's going to print confused because I have a Z inside of there and nothing else matches. Now I want to go and take a look at the while loop again, and I'm going to cover a couple other additional things. So we're going to create this guy that is going to determine when we leave our while loop. So I'm going to say that I want to continue looping as long as I has a value that is less than 20. Then what I want to do is, if I only want to print odd values, what I can do is I can say if I, and this is modulus, and what modulus is it returns the remainder of a division. So in this situation, if the value is a multiple of 2 or even, it's going to return 0, and 0 in C is exactly the same as false. So we're going to come in here and we're going to print out I if that is true, that it is an odd value. And then we're going to increment the value of I. Very important to do that. Then, well, let's go and I'm going to show you something else. Let's say that I then want to jump back to the top of the loop up here and to continue with our while loop, but skip everything that follows afterwards. I can just type in continue, and it does that for me. Now what I'm going to do is put another condition inside of here, and this is going to loop as up to the value of 20, but let's say, I mean, this is obviously just a silly thing to do something, but let's say that if it hits 14, I want to break out of the value. That is going to break completely out of the while loop and come down here right after the while loop ends, or right after this, and that will be the end of that. Then I'm going to go and increment I, and if I run it, you're going to see that it's going to print out all the odd values and stop whenever it hits 14, which is exactly what it did. Now to save time, I'm going to cover a whole bunch of math functions. So let's just go through them one by one. Of course, we can add values. We can subtract, multiply, divide, and do the modulus. Remember, it gives you the remainder of a division. We can do absolute value. Of course, this is going to return a positive 2. We can just go and run that, and you can see the result. results over here on the right side of the screen. Min is going to return the minimum of these two values, which is going to be 2.5. Max is going to return 3, of course. Rounding is going to round up in this situation to a 3. Anything over 0.5 is going to be rounded up. Floor is going to round down everything, and ceiling is going to round up everything. So even though this is 5, this is going to turn into a 2. That's going to turn it into a 3. This is square root. This is square. This is the power. So this is going to be 5 to the power of 2. Cube root. And then we can also calculate logarithms, and you can see both of those guys. And you can also see the results of those different calculations, math functions. And you can go and get the code. It's free in the description if you would like to take a closer look at that. Well, I'm trying to save time. So now what I'm going to do is I'm going to cover something else, which is constrain. And what it does is it allows you to constrain a value between a range. And what I mean by that is, if this is going to be the function, the different pieces we're going to throw inside of it. So it's going to return the value of x if x is between a and b. Otherwise, it's going to return a if x is greater than or less than a. So in that situation, it's going to constrain everything between here unless it falls in between it. So let me show you an example. I'll show you exactly how it works. So let's go and print out this information. And we will just simply say constrain. And this is very useful in electronics. And 5 and 1 and 6. And throw that inside of there, and close your parentheses, of course. And then we can run it, and you're going to see that it goes and prints out the value of 5. Why? Because 5 falls between 1 and 6. And you can go in there and play around with that to see some other things. But later we'll do some real live projects. Also, we're going to have some trig functions, of course, so those will be quite useful, especially in electronics, and there are all of those. And another thing we can do is, let's say we want to generate random values. Well, what we're going to have to do is we're going to have to create a random seed that is basically, if you just call for a random value, it's going to be the same every single time the program runs. So what we need to do is initialize the random number generator we're going to be using here in a second with a random seed value. And what we're going to use is an unconnected pin, which is going to provide us with a random value. And the reason why is it's going to be a floating value. And we'll get more into that later. So then, let's say I want to go and create a whole bunch of random numbers. So I'm going to go int I is equal to 0. And we're going to cycle through as long as I is less than 10. So we're going to create 10 random values. We're going to increment it, of course. And then to actually go and create our random value, we're just going to say random. And we're going to say that we want a value between 1 up to 10, not including 10. So it's going to give us 1 through 9. Whoops, what did I do here? I forgot to put 0 inside of there. So let's save that and run it again. And also that has to be uppercase. And let's run it again. And you're going to see that it goes and it generates 10 random values. All right. And what else are we going to do? Let's talk about bit manipulation. Of course, that is very, very useful with electronics. So basically, what we are going to do, well, I have to cover the basics here, sort of. Basically, there are 8 bits in a byte, and each bit is going to be a binary digit, meaning it has a value of 0 or 1. And I have other tutorials on how binary works, and if you leave a comment below, I'll go and I'll link to it. But basically, I'm guessing that if you're into computers, you know how binary works. Basically, this is how we are going to be able to calculate different values. So if we have 1, 1, 1, that is going to be like 1 to the 2 to the power of 3, 1, 2 to the power of 2, 1, 2 to the power of 1, and 1 to the power of 0. And those, if they are all ones, are going to give us a result of 8, 4, 2, and 1. If we add all those up, that's 15. And that's how we go and convert from base 2, which is binary, into base 10, which is what we all use. So let's go and create some of these guys. Let's go, and binary 1 is going to be, I'm going to have them set as integers. If we want to actually use binary, what we're going to do is just put a 0 and then a B in front of it. So we could come in and say this, like that. And this is going to be equivalent to 170. You have to trust me on that, or you can go do the math. And let's go and let's create another one. And let's just have every single one of these be 1. Okay, so there's 4. All right. Now what we're going to do is do some bit manipulation. Okay, so we can, if we go and do bin 1 and bin 2, what it's going to do is it is going to return a value only if both of these are 1s. Okay, so in those situations it'll be 1. In this situation where there's a 0, it's going to remain 0. So what do you think the value is going to be? Take a wild guess, and if I didn't type it in wrong, you would be able to see that bin 2. And let's run it again, and you're going to see that the value is going to be 170, exactly the same as what I had right here. All right, and there's other bit manipulation tools available to us. Let's just go and copy this, and the OR is going to return a 1 if either one of them are 1. So guess what the return value is going to be for that guy. And let's go into a couple more. There's also exclusive OR, which is going to return a 1 only if one is 1 and another is 0. And that is how we do exclusive OR. We're also going to have another guy inside of here, and the bitwise NOT is basically going to convert each to its opposite. So no matter what it is, it's going to give the opposite of that, and we're going to throw a tilde inside of there. And let's just go 0, B, 0, 1, 1, 1. And that's actually going to give us a negative value. And the reason why it gives us a negative value is the top bit in any number is what is called a sign bit, and whenever it is changed to a 1, that makes the value negative. So that's the reason why we had that. We're also going to be able to come in and shift bytes. So let's come in and let's do it to bin 2. Let's say we want to shift bin 2 by 2 over. That's how we do that. And we're also going to, let's copy that and paste that there. Let's shift it over to 2 bits to the left. And this is going to give us, well, it's going to turn it into, let's put a comment inside of there, 0, 0, 1, 1, 1, 1, 1, 1, because it shifted it to the right. So that's going to give us a smaller number, while if it went to the left, it's going to give us the full amount, this guy right here, and then 2 zeros on it. And if we run it, you're going to see that, in fact, that is true. And that's all we're going to do with bit manipulation right now. And now I'm going to talk about structs. Now, basically, structs allow us to create custom data types. So a custom data type that would be useful would be RGB. So let's say we wanted to have a red represented inside of it and a green, and this could be used with an LED to go and change different colors. Make sure you put a semicolon here down at the end, and make sure you put a semicolon there so that that works. And what that's going to allow us to do is we're going to be able to go in and use our custom data type to define a color, and then we'll be able to assign those values. So let's come in and do this, and there we go. And then we could do something like if a color is red equal to, and color is green is equal to 255, and color blue is equal to 0. Well, in that situation, we could then say that, yes, indeed, we are dealing with the color green. And it's green, and there it is. And indeed, it is green, and you can see that it's going to print out it's green after it does that. All right, so quick example with structs. And now let's talk about STRUX. So let's say, whenever we're using the regular serial to print out things, it's very hard to style the information the way that we want to. So for example, let's say we wanted to print out a time with 2 values and a colon in the middle of them. Well, let's go and do that. So this function is going to receive an hour. You could also do this with seconds or whatever. So there's that guy, and it's not going to return anything. That's the reason why void's there. So what we're going to do is we're actually going to create what is a buffer, which is going to store some information for us, which is going to be the time. So we can go do that, and then I can call sprintf and buffer, which is where this string is going to be stored at. And then inside of it, what we can do is, let's say we always want to have 2 digits, guarantee that we have 2 digits. Well, we can go in there and put 02 and D, meaning that this is an integer. And we can go 2 inside of there and then close that off. And then what we can do is put hour, and the hour is going to go here. And then we can put in minute, and the minute is going to go right here. So that's a way for us to style our stuff. So we can then go style printf and print our buffer, and it's going to print it the way that we want it to. And now we can jump back up inside of here, and we can just go print time and then pass in 1, whoops, and 12 and print time. There we are, and run it, and whoops, what did I do? Printf, there we go, and let's run it. And you're going to see that it's going to print out the time the way that we would hope that it would print it out. And it does. All right, so good stuff. Now let's talk about pointers, which is something that confuses a lot of people, but it really shouldn't. It's not that confusing. So I'll give you a couple examples. And basically, a pointer, it just refers to a memory location for a variable. So let's go and create one. So this is a pointer. I put the star in front of there to represent that that is a pointer. Then I'm going to come in and I'm going to go value 1 and say that it is equal to 15. Now, if I want to store the memory location for a variable in a pointer, I just go pointer is equal to and val1, and then it is in there. And I can come in then and print out the value just by putting the star in front of the PTR. So it switches it back, and you're going to see that it prints out the way that we expect it to. And there it is, there's 15. So what else can we do with it? Well, let's go and create an array of primes. So it's equal to 2, 3, 5, and 7. All right, so there is our array. And let's print, you can print, but basically an array is actually a pointer. And you can actually quite simply come in here and print the first index, just by going in like this and primes and run it, and you're going to see that it prints out a 2 on the right side of our screen, as it did. Another thing that's kind of cool is we can go and get the second item, if we would like, out of the primes by just coming in here and going 1 like that, and we will get the second value, which is 3, which will show up on the right side of the screen. So cool stuff. And let's do another one. Let's say we want to go and print out an array. Well, we can go void and print array. We want to pass a array into here. We're just going to go and designate that this is an array being passed inside of it, and we can close that off like this, and then we can create a for loop. Int I is equal to 0 while I is less than size and I plus plus. The size is going to represent the number of items that are inside of our array. We're going to have to pass that information inside of there, and then we can go in and print out each of our array items just by using our index notation like that. And then we can come up inside of here and just go print array, and how we pass our array inside of it is to go primes and then the total number of items, which is 4, and everything is working the way that we would hope, and it's going to print out all of those prime values. Okay guys, so there is a rundown of the vast majority of what you're going to do with just the core C language using Arduino. I hope you guys found that useful, and I'll be doing hardware videos, and connecting LEDs, talking about electronics, just making a ton of different stuff, all based off of whether you guys like these videos or not. So please leave your questions and comments below. Otherwise, till next time.